I'm Tim Ventura, and in this presentation, Rob Chambers discusses British Aerospace's Project Greenglow and describes key experiments to connect gravity and electromagnetism that were funded but never satisfactorily concluded during Greenglow's existence. Rob is an aerospace systems engineer with over 25 years' experience in inertial, satellite, and terrain navigation systems. He has a bachelor's degree in physics and computing from the University of Kent at Canterbury, where he studied under Professor Roger Jennison and Dr. Lewis Ryder, and prototyped the thermal properties experiment for the surface science package of the Huygens probe to Titan under the supervision of Dr. John Zarnecki. From 1999 to 2005, Rob contributed to BAE Systems Project Greenglow, managing its online infrastructure and assisting with analysis and review of technical proposals.
Right. Yeah, just a little introduction. This is something I've had on my wall in my office for a long time anyway. It doesn't really go down very well with people who are funding projects, though. That really the whole point of it is that you don't really know what you're going to find, but increasingly people have to say, oh yeah, I'm going to spend so long and I'm going to find this or that, and it's not always guaranteed. So in terms of what I want to cover really is a little bit about my own background for people who don't know me. I'm sure a lot of the old guard probably remember me from 15-20 years ago. I was a little bit more active in those days. A little bit about Greenglow, my involvement with it, meeting with Evgeny Podklatnov, and some of the more recent things he's been working on. And also wanted to look at one of the experiments which was begun with Greenglow's assistance, but was never really completed, mainly because the people involved moved country effectively. So the experiment was never really finished. Afterwards, we're going to look at the university roundtable discussions that took place before Greenglow and kind of were one of the stepping stones towards Greenglow. There were a couple of elements of that which there are some, well, new developments or some things which were suggested at the time, but again, no action was really taken. And afterwards, I'm going to discuss a little bit about bismuth and diamagnetism. This is something which comes up a lot in the history of alternative propulsion or gravitational research for over a century now. And at the end, really, I just want to give you some ideas for replications of experiments which, to my knowledge, again, I've been a little bit out of the loop, for a few years, but to my knowledge, there are a few things which could be explored. So I'll just start a bit with my first activity, really, well, my first and last so far activity in space and related research at university. You can see me circled there on the left. This is a screen grab actually from a documentary called Destination Titan, which you can find on the internet. I'll drop links to all these things in the chat afterwards. And this was to develop a thermal properties experiment. So for the Titan probe, specifically it's the surface science package of the Titan probe. And here I was working with people from European Space Agency, Rutherford Appleton Labs, and so on. You probably won't know any of the people in the picture. You might recognize this guy in the front row with the tie because he appears on every space program that discusses Titan, Saturn, Cassini, that kind of thing, although he professes to hate the media. He's called John Zarnecki, and you may have seen this program possibly on Nova. It was produced by the BBC, but I'm sure it's been sold overseas. And so anyway, that was an interesting experience. As I say, the one upshot of this is that I have my signature somewhere engraved on the probe, sitting on the surface of Titan, which is probably about as close as I'll ever get. But yeah. Anyway, so I graduated in 1991. In 1996, I was hired by British Aerospace, as it was called at the time, in Plymouth, which, as you probably know, that's where the Pilgrims came from. And a lot of the work there involves gyroscopes because it historically was part of Sperry gyroscope, where I think Roger Sawyer also worked, but he was there many years before me. And because of the involvement with gyroscopes, I obviously picked up a lot about how they behave, the use of quaternions, the Sagnac effect in laser gyros. And I've included a picture of Eric Lathwaite, although I didn't meet him. He gave a talk there a few years before I was there, which was not well received. There were a lot of gyroscope experts there, and they disagreed with him quite strongly, from what I hear. So, moving swiftly on. So when I was there, each part of the company works fairly independently. There's not much communication, or at least in those days, there wasn't much communication between the different sites. So it wasn't until about 1999 when we had an intranet introduced. We still didn't have internet access in those days. So I thought, oh, well, this is interesting because I'm hearing a lot about UFO sightings around BAE in Wharton, which is near Liverpool. And people are saying, oh, yeah, I'm seeing all these strange things flying around. So I thought, oh, well, I'll investigate a little bit on the intranet because I know that historically there was a lot of involvement with stealth and that kind of thing at the site. So there was originally in the mid-90s, there was a lot of speculation about something called Halo, and nobody really knew what it was. It could quite as easily be just a normal plane with a bit of extra radar absorbent coating as some new invention. So I thought, well, I'll see what I can find out. And really all I found was Greenglow. I found references to Ron Evans's work and Greenglow. And so I thought, well, I'll contact him and offer my services pretty much as, I guess what you would nowadays call a social media manager, trying to use the name, the company name, to kind of give some weight to getting people together by email, because mailing lists were about all that was available in those days. And excuse me a moment. Yeah, so as it turns out, the BAE have also, in the meantime, been developing other platforms, something called Replica, which is, I assume, some kind of drone mock-up, and also Tyrannus, which is it is an actual UAV, a thing which actual physical thing that's been developed. And so, yeah, I discovered the existence of Project Greenglow. It was not advertised much in the company. So, and I think here I've probably got all the surviving artwork from Project Greenglow. There were a few other paintings that have been done, but these are the only ones that survive as far as I'm aware. Maybe, I think Rod Evans might be with us. He might know of some others. Just check and see. Yeah. So, yeah. Also, when I developed this presentation, I went and looked through my email archive because I tried to keep as much as I could from those days. So I was able to trace, or I did a bit of investigation as well to see who was still around. So Tim, obviously, I talked to, Mark Millis, Ron Keeter, obviously. Other people, there's Pete Skeggs, who was also someone who developed or tried to develop a Pokletnov type experiment. Joseph Hiddink, who I think died quite a while ago. Steve Burns, who developed a lot of experiments. I've been in touch with him recently too. I'll talk more about him later. Nick Cook, Gary Stevenson, Tom Mahood, Paul March, Myron Evans, David Maker. Also, and probably this is the biggest sort of disappointment really of that period, was Marcus Hollingshead, who I know Tim's has talked to as well before, which we never really got to the bottom of whether it was a hoax or whether he chickened out at some stage, maybe too much publicity, he was scared off. We still don't know. And as part of these were all things which arose out of the creation of the mailing list, which we had internally and externally. which I think I had the help at the beginning with Berkant Goksel, who may or may not be connected, I'm not sure, who is still active as in electrohydrodynamics and dirigibles, I think. In terms of my kind of public-facing involvement, I did a couple of articles for Fortean Times, which I think Tim has a copy of because I needed to use some of his photos. So I sent him a copy of the magazine. It's not what they would normally call a skeptical magazine. It's a skeptic with a C rather than skeptic with a K, is what we say. It's fairly open-minded, and I had a good personal relationship with the editor and a lot of the staff, and they encouraged me to write about it for them. And however, I think I upset their usual science correspondent, so that was the last time I wrote anything for them. Also, after Ron retired and the BBC were again interested in the subject, in 2016, I was asked to provide archive material because as part of my efforts, really, which were entirely voluntary. It was a completely unpaid position. And so I undertook to try to archive as much material as possible from not just internally, but from the wider community, because this was in the days before Sci-Hub and Library Genesis. There was no easy way to find something unless someone offered it to you or told you where to find it. So it was useful for the editors and the producers of the show to give them some background information. So, okay. Yeah, and so in terms of my activities within Greenglow, I was able to arrange to visit Wharton with Ron Evans when Evgeny Pokletnov came to visit as part of he was coming to help Sheffield University do their replication work. However, it was not the same arrangement, and so we think that may have had an influence on why it really didn't pan out, because it was being driven by a motor, not by the field. And so, again, this is an example of the brain drain, which is typical of British universities. The guy running it, Dr. Clive Woods, went to the US, Iowa State University, then Louisiana State, and he seems to be sort of an administrator now, so he doesn't do any active research. And so there was no further progress at that stage. So, yeah, and I also, as part of my research for this presentation, I found that there was another interview with Pokletnov, not just the one that Tim's done, but another one which claims to be with him, where he stated that he doesn't now think that it's necessary to use a superconductor, that he's used a conductor successfully with a rotating field to create the same effect. So it seems to be, this is my guess really, that the field variation, magnetic field variation, seems to be the key. If there is an effect, then that may be the key to an effect. Just a quick update. This is, in fact, this slide I produced before I saw that Tim had done something quite similar with his recent interview with Pokletnov. So I'm really just quoting from an email that Pokletnov sent, where he claims that his latest work is really based on the German flying discs of World War II. I'm not sure how exactly we can prove that. However, that he's improved it by adding a nano coating, which I think is gold, or some part of it is gold, and that this is the so-called torsion field, which this is his belief, which has the same structure as the gravity field as predicted by Einstein. I can try to play these. I'm not sure if my bandwidth will do it. I can try playing one of them and seeing if it's only about a minute long. There's a lot of the discussion is in Russian, so I'm not sure if it's useful, but I can try. As I say, these are available on Tim's own website and on YouTube if you want to look at these again. And if there is anyone who knows Russian, or if I think someone had access to a Russian translator, then there might be something useful there. Right. Yeah. Okay, and this next section is about one of the experiments which is not strictly gravity related. It's more of a, as I understand it, more of a very efficient light sail made with by using a resonant cavity and focusing microwaves. And again, it's one of these things which was started but never finished because the people involved moved to another university in Australia this time. So it's using the standard radiation pressure model, and initially using a single cavity. So you're focusing microwave radiation onto a cavity, which is like if you imagine a sphere with a section taken off the end. And it was then found that in fact it was more efficient to use a double cavity. So you have essentially an open resonator with a standing wave inside. And this kind of put me in mind of the EM drive as well. So I don't know if there is any kind of connection there with efficiency, with the way that microwaves could be trapped in a cavity. I'm no expert in microwaves myself, but reading through the papers that covered this, they had to, again, tune it very carefully. This seems to be a common thing with microwaves, that they have to be very carefully managed. And it was not taken any further. This was in about 2001, that the people involved, I think it was Dr. Paul Smith, I think, and Sergei Vinogradov, who had come from Ukraine to Scotland and then to Australia, both went to Macquarie University, I think it's pronounced, in Sydney. And I did a little bit of investigation because I thought, are they still there? What's happening there? And they don't still appear to be on the staff. However, there is someone called Elena Vinogradova, who, if I understand the Russian terminology correctly, is possibly his daughter. So, and she's also an expert in microwaves, and potentially she may be able to give some advice if someone wants to try to replicate this or do further work. She may have some background knowledge which could be useful, or indeed for any other microwave experiments it might be worth asking. Yeah, so I would imagine that if you had for example, a large matrix of these kinds of cavities, you could have a very efficient light sail. I would imagine that's the end game for this. Right, and okay, I'm just the next section is about a precursor to Greenglow. In 1990, Ron Evans convened a roundtable to discuss gravitational research with universities in the UK. And after his presentation in January, I think it was, I thought, well, one of the things he's very interested in is replicating Faraday's experiment from 1849. Yeah, I'll just cover here also. I think that the timing of this was interesting because it was not long after Hayasaka's 1989 paper that concerned the weight loss or apparent weight loss in gyroscopes when they're spun in one direction and not in the other. And in fact, this is still currently under investigation. There's someone called Nuno Santos in Portugal who claims to have an explanation in the context of something called de Rham cohomology, which I know nothing about. It's over my head, but perhaps it means something to someone. And this roundtable, they covered conventional research in radiometry, astronomy, and at the time there was a lot of discussion about a possible fifth force beyond the four known forces. And there were also more speculative topics about microgravity and the relativistic wave model of the electron, which I'll get to in a moment as well, and an experiment to detect any links between big G and permittivity and permeability, which I will go into in more depth in a moment. So, yes, to get back to Faraday's experiment, you may remember, if you were there, Ron Evans discussed the experiment which you'll see in the sort of brown square on the left-hand side. where you would drop a mass with a coil wrapped around it to detect any changes as a result of movement in the gravitational field. So I did a little bit of searching to see if anyone else had looked at this. And there was someone called, Dr. James Overduin, I think that's how it's pronounced, and Daniel Zeil, who was one of his students at Towson University in Maryland. And they proposed to do the same thing, but rotating it, instead of having one long drop, have lots and lots of small drops, effectively, which seems to be quite a reasonable idea. However, if you look at their paper and read their equations, when I showed this to Ron Evans, and he said, yeah, it's a good idea for an experiment, but the way that they've done their calculations, they seem to have confused the directions of gravitational and gravitomagnetic flux somewhere along the line. So I'll drop a link to this paper into the chat along with others. And so if anybody does look at this, you should bear in mind that there is a possible mistake in their equations. And I'll be happy to supply the diagrams that Ron gave me to demonstrate the problems with it. So again, this is something which potentially someone could do, probably not too expensively. And so the next section, there was concerns. Some of you may have heard of someone called Roger Jennison, who was in fact a professor at my university, and I didn't realize anything about him at the time. But he was a typical, what you might call, British eccentric. To us students anyway, we thought this guy is the eccentric, mad scientist type, but a very nice guy. But with a very wide range of interests. He was interested in ball lightning. In fact, as a witness, there's a very famous letter he sent to Nature, the magazine, where he described he was on a plane on the east coast of the US. This is in about 1968. And he saw a ball lightning travel down the aisle. And so he made observations because he said, this is great. I'm an expert in electronics and electrical physics, and this is I'm the ideal witness for this. So he tried to make as many notes as possible. And this, I think, informed his later work, where he was looking at modeling particles as in terms of a trapped wave, which I'll describe a little bit more in a moment. He's also very interested in dowsing, and he's quite an accomplished artist as well. But one of the interesting things, and something which has been picked up by people like Larry Reed in Quantum Wave Mechanics, which is a recent book. He'd also be an interesting person to get on here as well. But the key thing with Jennison is that he showed that standing electromagnetic waves in fact, relativistic phase-locked cavities can exhibit rest mass and inertia, so that you can model an electron or another a fundamental particle in such a way that it creates all the things that we identify with inertia. So there's no need for Mach's principle, that there is an actual something which falls out of standard relativity and standard physics, which can create inertial effects. So Newton's laws equals mc squared, everything else can be modeled in this way. And he wrote a piece for sort of a what would you call that, sort of a public science, popular science magazine, Wireless World, an article called What is an Electron, where he describes some of this in relatively easy to understand terms. It's not, his papers aren't actually too difficult to read. And he has physically created this as an experiment. He seemed to be very good at turning these sort of ideas into experiments. There was another, he's also been able to slow down electromagnetic waves to a stop and in fact reverse them. And he demonstrated that if you decelerate a wave, an electromagnetic wave to zero, you end up with an electrical charged dipole. So it also kind of puts me in mind of Feynman's diagrams, where when you have an electron and positron, you create an electromagnetic wave, or you could think of it as releasing the wave and then creating it again by forming particles from it. And so this idea of trapping waves in phase-locked cavities, particularly microwaves, again puts me in mind of the EM drive. although of course that's not a standing wave. But it does make it an interesting comparison with the fact that inertia arises from it. So as part of the roundtable discussions, he also proposed some experiments to try to see if there is a connection between big G, so the gravitational constant, and electromagnetism. So we could assume that there's a link between big G and permittivity and permeability. And Oliver Lodge in 1920 said, well, essentially said, I wouldn't be surprised if there was a link. He's not saying there is, but it's not outside the range of possibility. And so to try to find this kind of link, he proposed, first of all, that you have capacitors spaced around a spinning disk where you have large masses. And you spin the disk and you try to see if there's a variation of capacitance as the mass goes around, goes past the capacitor. And he thought, well, this isn't a great, there's a lot of problems with this potentially. So in terms of actually creating something that works without vibrating too much. So he proposed an improved version where you actually make use of the Earth's gravitational potential gradient by putting a tube. You essentially rotate a tube vertically, and the tube has a capacitor at each end, and you use a capacitance bridge to look for variations in the capacitance, which presumably will be a result of being in a different position in the gravitational field. However, you need to be able to detect a change down to a level of 1 in 10 to the 8, which he seemed to believe was possible with 1990 technology. So I know nothing about capacitance bridges myself, so I'm not sure if this is possible or practical, but it's an idea for an experiment, which again doesn't seem to be too difficult or too expensive for someone who's interested in doing that. So this is the kind of apparatus that he was considering. So you just simply rotate a tube at perhaps 1 revolution per second, so you don't develop too much acceleration at the end. So it's about 1 g at the ends. And you can monitor then the differences in capacitance. And he also proposed then you could do it horizontally. You could replace the dielectric with something else to see if a different dielectric had different effects. And I've just provided some theory that, in fact, this is just lifted straight from the roundtable document, which I think hasn't had a lot of attention because it's not been, I mean, although it is unclassified and available to everyone, it isn't actually, I wasn't able to find it on the internet, put it that way, apart from my own copy. So I did take the liberty of putting my copy onto the Internet Archive so that it's available, or hopefully should be available fairly soon to everyone. So I can run through the theory quickly. Is that essentially if you assume that there is a relationship between big G and C, I've seen people do something similar. However, it seems to be more like a goal seeking with extra steps, that they assume, they take constants and they say, well, how can I create this constant from that constant? And they don't really apply any logic. They're just saying, oh, if I divide this by pi and multiply it by e or something, then I get the right answer. Here we're just kind of assuming that there is some function, a function of c squared, which equates to gm over r. So if we assume it's something of this form, so it's c squared minus c dash squared, and you create c dash which is of such a form that when it goes to 0, you're left with gm over r is c squared, and which is essentially r gm over c squared. So it's the Schwarzschild radius, which so we have a grounding in something which is real, which exists already. So you can rewrite this in terms of the permittivity and permeability. So you can say, okay, we should be able to see a difference here, and a difference in gravitational potential between the capacitor positions. We can use that together with the length of the tube. We can say that as a fraction of the gravitational potential at the surface, if you have a 1 meter tube, you have about 1.5 times 10 to the minus 7. So clearly, if you had a longer tube, you could reduce the need for accuracy. And if that relationship does in fact hold, then you should see a difference in your permittivity and permeability in the top and bottom position. So again, this is something which is probably not too difficult to do. It's not going to take you to another planet, but it is interesting to be able to prove a link that has not really been demonstrated by an experiment before. So for the next part is just some speculations really about bismuth, diamagnetism in general. Bismuth is something which has been something which has drawn the attention of physicists for gravitational research for over 100 years now. It's strongly diamagnetic, so it stands out among other metals and elements. It's also in the same group as the infamous element 115, now called moscovium. So it's I suppose it's a natural thing that people will say, well, if bismuth does this, then 115 must be even better. It must be even more diamagnetic, even more useful for this kind of thing. Now, so as far as I've been able to tell, it was Charles Brush in the 1920s who first looked at bismuth. In fact, because of its diamagnetic properties, he thought, well, there's something interesting going on here. Perhaps we should compare it with other metals that are standard, that are not diamagnetic at all. So he conducted a huge variety of experiments, and it seems to be very, very carefully done, very detailed. There's an experiment where he used a pendulum and timed it against other materials. He did everything he could to balance out the air resistance and vibration and everything else. And he, as far as he was concerned, essentially it falls faster than, for example, zinc or aluminium. Now, this pendulum experiment was refuted by, I think it was Harold Potter, not long afterwards. However, I don't think any of the other experiments which he did were ever challenged. I think because people thought, well, okay, we've disproved the pendulum and we don't need to worry about the other experiments. So there may be something to that. It seems odd that those have been abandoned and never challenged. Other people, for example, Wallace in the 60s and 70s, in his patent, he said that bismuth was preferred, and as far as I can tell, this is because it has a very large half-integer spin nucleus, because his invention relied on aligning nuclei in the same way as happens with something called the Barnett effect. When you align magnetic domains, you end up with a charge, I think, you rotate a ferrous metal and you end up with aligned magnetic charge. And he was investigating whether something similar would happen with gravity. And again, this issue of spin-aligned nuclei, that also put me in mind of Alzafon's experiments, that maybe there's some connection there. Now, Wallace's patent, his main claims were tested by Martin Tedmar in Austria, as far as I'm aware, but the figures 7.8 and 7A and 7B, which I'll show you on the next slide, as far as I know, it was never replicated in that form. The main claim is a device which is well, what he essentially is doing in figure 7A and 7B is he's turning his device inside out. When Martin Tedmar did his testing, he initially found a positive result, but it was found that it was vibration that was causing the result. So again, we're looking at something rotating in a magnetic field, which made me think again of torsion, perhaps. In the 1990s, then we also have something, well, we had arts parts with a collection of pieces which were claimed to be of extraterrestrial origin. From what I've been able to determine, there was an objection at the time that, well, there's no earthly process which could create this mixture, this blend. However, other people have said, well, no, this could be a waste product of something called the Bletcherton-Kroll process, where you use magnesium to take bismuth impurities out of lead as part of a lead purification. So I guess that's still debatable. In fact, Greenglow as well also sponsored a study which included a paper about thermomagnetic effects in bismuth and gravitomagnetism, but it's not as exciting as it sounds, because the paper kind of is in two sections, and I have the feeling the gravitomagnetism was kind of tacked onto the end for Greenglow's benefit, probably. So it's not as good as it sounds. And more recently, then we have something which the to the Stars Academy is claiming some sort of photonic metamaterial, a mixture of bismuth, zinc, and magnesium. This may or may not be the same as Art's parts, as far as I know. I've not been able to find out much about this. There's a claim that it's atomically aligned and possesses non-naturally occurring isotopic ratios and has many thin layers, and theoretical analysis showed that it acts as a waveguide for terahertz frequencies. But as I am no expert in microwaves or this kind of propagation, so I'm just reporting what I found rather than I have no opinion on that. So to return to Henry Wallace, then I've included the diagram on the next page, and so this 44, this outside shell, this is bismuth or another equivalent material, which is presumably a half-integer spin nuclei material. And inside you have a motor, which is driven by compressed air. I think he was very keen to avoid any kind of electromagnetic interference with his device. So it's very much a mechanical pattern, a mechanical design. So there's a wheel structure here. 23 is the stationary pole pieces which hold everything together. So as you can see, obviously vibration is a potential issue if you're trying to replicate something like this. It might be possible even, I'm not sure if you could use a CNC machine, for example, to create the shell necessary. I've not really looked into the practicalities of how you could do that. So, right. And here I've borrowed quite a lot from Ron Evans's presentation as well. So on the left-hand side, we have when you generate gravitational equations based on the electromagnetic equations. This is by analogy, it's probably not a perfect analogy. There's various reasons why not. I think usually the objections are that it violates the equivalence principle and that it's a different gauge, so that the electromagnetics is a dipole, whereas gravitation is a quadrupole. But in certain circumstances, like weak gravitational fields, the two types of equations, it's acceptable as an approximation to use this kind of expression. So just to compare really what we have in electromagnetism, you have permittivity and permeability, electromagnetic permittivity and permeability. And similarly then, if you accept this analogy, you can also say that you have permittivity and permeability of gravitoelectromagnetism as well. Your permittivity is probably fairly much fixed because it's dependent on big G again. The permeability, however, is very, very small, so 10 to the minus 26. This is something that Gary Stevenson covered as well recently. Also in reference to Robert Forward's work, where he also has this eta, which is the same eta. However, this is for free space. And Forward said, well, yes, that is the one for free space. However, as with electromagnetic transducers, for example, you may be able to find materials which have an eta, gravitomagnetic permeability, greater than 1. And he said, well, there probably are greater than 1 anyway, because they have spin, which means that it should, well, I didn't follow the maths exactly, but it he was of the opinion that it should be possible to find materials with an eta greater than 1. So I was just, this is a speculation really, that could diamagnetism itself be indicative of a relative gravitomagnetic permeability that you might find in superconductors, bismuth, parasitic carbon, or potentially you could imagine that there would be a metamaterial or nanomaterial that you could construct that would give you the property that you wanted. If we can produce a negative refractive index, then potentially we could maybe produce a permeability greater than 1. So this is just speculation on my part. Just for also to address one of the objections about the analogy, that it violates the equivalence principle. But it's already been shown that the weak equivalence principle, at least, is well, it is broken all the time. There's a famous paper by Donoghue and Holstein from, I think, 1987. It's called Aristotle Was Right, and it's essentially saying that through quantum mechanical arguments that heavier and colder objects will fall faster. They are more strongly attracted to or react more strongly in a gravitational field. And this is something which is picked up later on by Fran D'Aquino and Steve Burns, which is I'll discuss in a moment. So we'll just move on. And this is, again, just to remind myself, really, that all models are approximations. This guy, he's actually a statistical scientist, or statistician, rather. However, I think this is applicable to all science, really, that we have to be aware that what we're discussing are models of the universe, not necessarily the way the universe itself behaves, that there's no requirement on the universe to make sense, as someone else said. So that we have to be aware always that we are dealing with approximations, and not to lose sight of that when we get too far along in our speculations. So just to come to some ideas for experimental replications, again, as part of when I developed this presentation, I was looking back through the history of what I was, to the extent that I was aware of the experiments that were being performed at the time. And one which stood out, or two which stood out, what was called the System G and System H of, well, the theory comes from Fran D'Aquino in Brazil, but the experimental setup was designed by Steve Burns, who is still around. He doesn't use the internet much. He's on LinkedIn. I've talked to him occasionally, but he's not really interested in doing any further experimental work, which is a shame. There's a good description of the detail of how to create these systems. What essentially he's tried to do is to say, well, okay, if the Donoghue and Holstein calculations are correct, then if we somehow can transfer energy into a material, and they're using very, very low frequency radio waves, sort of in tens of hertz or less, I believe, that this would be a way of transferring energy into something which would reduce the gravitational effect on it. I'm not sure. Again, the problem is that System G, the only details we have really are on the JLN Labs website, and there were never any final results posted, probably because possibly or probably because it didn't work. We don't know. However, D'Aquino himself claimed that he had success with the successor, which is called System H on the right-hand side. It's not a great diagram, but there are other diagrams available. And so you can see you're transmitting a very, very low frequency radio signal in the hope that it is absorbed by a surrounding material, in this case iron, and that it will reduce the weight of that iron. And again, I'm not sure really if any other work has been done on this. I haven't been able to find anything recently. I know that D'Aquino himself is very hard to find and get hold of. And also a little bit of, I did a little bit of work on looking at what Jean-Louis Naudin is doing now, and he seems to be developing drones for the French military. So I don't think he's doing much work in the sort of experimental space nowadays. Another idea which I came across looking at the M drive and Mike McCulloch's work as well, that there's someone called Diaz in Spain who's developed a photon or photonic loop, where he believes that different curvatures in the path of an electromagnetic wave will give you a different sideways force. So that like a car on a racetrack is pulled more strongly on a tighter curve than on a wider curve. They claim that their thrust effect is about 4 times above noise level. This has also been replicated by Tamar unsuccessfully. So this is something which appears to be, I guess, fairly simple to replicate. It seems to involve just a coil of fiber optic and a frame, appropriate sized frame. And there's some experimental details here from a presentation from Diaz, which again I'll put a link for this in the chat. So again, this is a possibility if someone is looking for something to replicate. This could be an example. Just a final thought really about, because we've discussed sometimes in the past, the cavity structure effect attributed to Grebennikov and others, that you have these microstructures that he claims is important for the effect. And this is again idle speculation on my part really, that this could be some form of natural metamaterial. That may be that it has some enhancement of frequencies in the far infrared or microwave range, given the dimensions that we're looking at here. Again, this is speculation on my part. There's no physical justification that I know of, not in standard physics anyway. And just as a final thing to remember is that you are the easiest person to fool. So you have to guard against that and try to look at it from other people's point of view. If you're doing an experiment, try to think of ways that you could be mistaken. It's an important principle to bear in mind. And also, just as a final thing, I should probably say that Ron Evans's new book is out soon. So I'll plug his new book in the chat, if he doesn't mind. So I think that's all for me. So thank you for your attention.